This is Algebra 2, Chapter 13.2, Exponential Growth Functions. We have an essential question. How's the graph of g of x equals a times b to the power of x minus h plus k, where b is greater than 1, related to the graph of f of x equals b to the x? So for this, I'm going to go ahead and start talking about this f of x equals b to the x. If we have a function f of x equals b to the x, and I'm deliberately leaving some space here, this b here is what we call the base of the exponent, okay, the exponential function. And what we have is, in making the transformations above, we have a, which is the number out in front, and this is going to be called the initial value, or we could call this the y-intercept. Okay, now we have the exponent here. Now we can move the graph of this function left or right by subtracting h. I hope that looks familiar. We've been using that all year. And then we have at the very end this plus k. And k will translate this function up or down. And a negative sign in front of the a will reflect this function about the x-axis. Now the base for growth, base is greater than 1 for growth. Now, as far as the real-world uses of exponential functions, exponential growth functions in particular, there are many, and I'm just going to list 4 and an additional bonus today. Population growth, money growth, the world of finance, musical tones, growth by cell division. And there's going to be a 5th I'm going to add here. We're going to say we have a coronavirus epidemic in process right now, and we will say epidemic growth. Now, right now, around at least my part of the world, this epidemic is experiencing an exponential growth. Eventually, that's going to change to we call a logistic function, but that's very much in the news right now and very relevant. So if you just look at these things together here, I can't really think of any type of function that has more real world uses in our society and on Earth right now than the exponential function. So we're going to be examining that relationship here. And here we have Explore 1, graphing and analyzing f of x equals 2 to the x and 10 to the x. So in this case, our bases are different. And what we have is that if we have x and f of x, well, if we have x to the power of, or 2, let's put it this way, 2 to the power of negative 3, that's going to be equal to 1 over 2 to the 3rd power, which equals 1 over 8. Okay? And then if we have this negative 2 for an input, we have 1 over 2 squared is going to be 1/4. And then if we have negative 1, we have 1 over 2, which can be 1/2. And then if we have 2 to the 0 power is going to be equal to 1. And any number to the 0 power is 1. And 2 to the first power, which is 2. 2 to the second power is 4. And 2 to the third power is 8. So what we have is not a constant rate of change, but a constant growth rate. So to get from one successive term to the next requires multiplying by a factor of 2. And then if we use this next function, p of x equals 10 to the x power, we're going to have 1 over 10 squared, or 10 cubed, excuse me, which is going to be equal to 1/1000th. And then for a -2 for an input, we have 1 over 10 squared, which is going to be 1/100th. For -1 for an input, we have 1 over 10 to the 1 power, which is going to be 1/10th. And again, 10 to the 0 power is equal to 1, and 10 to the first power is equal to 10. 10 squared is equal to 100, and 10 to the third power equals 1000. Now next, we're going to be graphing these really quickly. Graph the parent functions, and I'm just going to go from memory. On this one here, we have f of x equals 2 to the x power. It's going to be this one right here. So we have, for -3, we have 1/8. I'm just multiplying by 2. 1/8 times 2 is 1/4. Times 2 is 1/2. Times 2 is 1. And again, for an input of 1 times 2 is 2. And 2 times 2 is 4. 4 times 2 is 8. And so this is what our graph is going to look like. Okay, it's kind of a little clumsy drawing this. Okay, more or less. Got a little off here. Anyway, now for this, p of x equals 10 to the x power. For -3, we have 1/1000th. Then we have 1/100th, and it looks like it's almost smashed right up against that x-axis. And then finally, at -1, we have 1/10th, and then we have 1. And then if we put in 1, we get 10. So this is 6, 7, 8, 9, 10. So I hope you can see somewhere up here. So very, very steep. It's going to be harder to draw. So you're smashed right up against that x-axis, then boom, way up here like this. Going straight up. Something like this. So I hope you can see the steepness of this. The one on the right is much greater. And then we have we talk about the domain of each function. We have x. The domain of this function is x such that x is an element of all real numbers. So x is an element of all real numbers. And the domain of p of x equals 10 to the x power is the same. X such that x is an element of all real numbers. And there are different ways. The interval notation is going to be this one right here, negative infinity, infinity, that's going to be interval notation. And for the range, well, the range is going to be y such that y is greater than 0. And the same for this p of x equals 10 to the x. Y such that y is greater than 0. And the y-intercept of each is going to be 1. Now we can tell that if we go back to our table. Okay, we can see our y-intercept where x equals 0 is 1 in each case. So 0, 1, 0, 1. And then it talks about the trend of each function. And I'm going to go straight to predicting. Okay, we have these graphs, and I already kind of explained what I wanted to on some of these things. And what's going to happen here is we have these values here. We have this 1/4 out front here. Well, that's going to be a, so that's going to be our y-intercept. So what this does, it vertically compresses by a factor of 1/4. Okay, now we have this graph of g of x equals 3 times 2 to the power of x. We have a vertical stretch by a factor of 3. Okay, now we have same type of logic here with this 10 to the x vertical stretch and vertical compression. Okay, now we have this negative sign, so we have reflected across the x-axis. That's what that negative sign does. And then we have it when we vertically compress by a factor of 3/4. So that's what we have in these here. This next one, graph of g2 to the x equals, we have this graph reflected across the x-axis again. That is what the negative sign does. And we vertically, in this case, stretch by a factor of 5. Okay, let's go on here. Now for C here, we have this g of x equals 2 to the power of x plus 1. This will be the graph of fx equals 2 to the power of x translates. We have this 1 unit to the, now which way is it going to translate? X plus moves to the left and x minus to the right. So it's x plus. So we're going to translate 1 unit to the left. And you should remember that from all the other functions we've been doing this year. Okay, next, the graph of g of x equals 2 to the power of x minus 4. It's the graph of fx equals 2 to the power of x. Translate 4 units, x minus to the right. So 4 units to the right. Okay, and then we have these with it, and for these exercises they're using 2 to the power of x and 10 to the power of x, but they can be anything to the power of x. We have this 10 to the power of x plus 2. It's going to be 2 units to the left. And then we have this 10 to the power of x minus 3, 3 units to the right. And you can test these on your calculator if you should have one on hand. Then the last thing here we're going to go over is this 2 to the power of x plus 3. It's the graph of fx equals 2 to the power of x. And the key is having this plus 3 outside. So that's in the place of what we call k. And so we're translating, in this case, 3 units up or upward. And this one here, to the power of x minus 5 halves, we're going to translate 5 halves of a unit. And we have minus here, and it's going to be 5 halves unit down. And then we have 10 to the power of x plus 5, that's going to be 5 up. And we have 10 to the power of x minus 2, we're going to have 2 units down. Okay, now I don't want to get into this discussion here. Let's talk about combined. Okay, we have your turn, and they're going to actually show a graph of what the graph of this looks like. And I'm gonna sketch this one really quickly. So we have this 4, that's going to be A, and that's our initial value. Well, our initial value is going to be 4, but we're shifting down 6. So it would be 4, but we're shifting that down by 6. So 4 minus 6 is negative 2. Okay, and then we have this 2x plus 2. Well, that's going to shift to the left. So we're going to go to the left 2 units. So that's going to be like our replaced y-intercept. And then we have this factor of 4. So we would have 2 to the, would be 1 would be 2. That's going to be times 4. So it's going to be way up here. And we could just make a table and input what that would look like. We would have between, what you can do is you can just take this graph that we looked at originally, where we have this, that negative 2, negative 1, 0, 1, 2, and we had this x, f of x, and we have this one here would be 1/4, 1/2, 1. This would be 2 to the power of 1 would be 2 and 4. And what we would do here is, for this one here, for g of x, we would multiply this by 4. So this would be 1. 1/2 times 4 would be 2. 1 times 4 would be 4. 2 times 4 would be 8. 4 times 4 would be 16. So just working to the, this is going to be our intercept, our located y-intercept. So what we would have is it would be like, this would be replaced right here. This would be our asymptote. So we go over here to the left 2 units. We would be at 1. We would be here for 1 unit to the left would be 2. Then we have our intercept here, and then 1 unit to the right would be 8. So you go up, because we went up 4. So it'd be way up here. So the thing would look something like this. And if you graph the calculator, that's exactly what you see. But you said, okay, this is 2 left, 6 down. This would be vertical stretch by a factor of 4. again, a calculator could help you with this, but really these things, especially this left, right, up, down translation, should be quite easy. And then we have this one right here. Okay, I'm just going to point out a few things. We're going to be, what is this negative sign going to do? It's going to reflect about x-axis. And this 3/5 is going to be a vertical compression by factor of 3/5. We have this x plus 2. What's that going to do? Translates two units to the left. And finally, this plus 3 is going to do what? Translates 3 units up. That's as far as I want to go on this today. This is going to be pretty easy, I think, as we go into working these through again. You take with you what you brought from working with your other functions. So good luck, and thanks for viewing.